to look at innovation, every innovation has to continuously access or generate two ends. The first one is problem identification and articulation. And here, friends, let me take a minute and explain very interestingly that problem identification is as important as articulation of the same. Sometimes we say we have identified a problem, but we have not articulated or we have not written it properly, and therefore the problem definition changes while we are doing the project, and or while we are talking to others, it may have a different solution. They may be seeing something else and you may be talking something else, and that's why problem identification and articulation is important. If you look at the next step, and the next thing that is required is, of course, creating the solution. We have to come up with the solution for that. And how can that happen is if we develop an attitude of problem solving. So let's look at our own environment and the world around. If you look at the world around and if you look at developing a problem solving attitude, what I'm saying is that while you are in the class and while you are studying any subject, while you study that subject, can you apply whatever you learned there to some problem that is surrounding you? And I gave you 3 examples how you can do that. And same way, if you are able to develop that attitude that whenever you learn a new subject, because engineering is basically application of science, and if we are application oriented people, that's why I said engineers are creators, because we apply, we don't use pure science, we take the science and we apply it to situation. That's what the job of an engineer is. And therefore, if we develop a problem solving attitude by looking at whatever you study in the class, can you apply it to your real life or the situation around? That kind of an attitude would generate a lot of interesting innovation in the colleges. Now we come to an interesting fact, and this interesting fact is about the framework that was created. And here let me take a small minute and say that you would be quite privileged in the sense that Gujarat Technological University has been able and is among the few university and colleges in the world that would have looked at this aspect of implementing design-driven innovation for subjects and for academic projects. So we are one of the few in the world at this time who would be implementing the latest. So you can understand, as I was sharing with you previously, that the awareness part is here. We are talking about bringing the best in the world to you through this framework. So let's look at how the framework works, and it's there on the screen. It begins with problem and objective. Select, define and articulate a problem, research, analysis and synthesis, and plan project. Let's look at this aspect. Here you would see that because it's an academic project, we are saying that the problem identification and the objective, selecting and defining and articulating, and then we are saying you do the research and come up to a plan of project. Why do we don't plan the project earlier? Why don't we say that, okay, problem and objective and then make a plan for the project? Because we want you to go through that system first of selecting, defining, research, analysis and synthesis. Sometimes engineers are excellent at analyzing things, but they are found wanting on synthesis. And here is an interesting fact that when you use both analysis and synthesis, you would be able to come up with better solution. And therefore, in this framework, if you look at it, we have kept plan of the project much later at this aspect, because we want that you look at a problem, look at the constraints while you do research, analyze what could be done better, and then come to project plan. After that is design driven innovation process, which we discussed before, that you could apply that here and then again look at that, is my project properly defined? If it is properly defined, then you move ahead. If you feel no, this project is not feasible, there are resource constraints, the research tells me that this is already there and it may not be interesting, then you again go back and have the problem and objective and start once again. So that's why here it is said. Then we go to idea generation, we go to conceptual prototyping, and then we go to testing and feedback. And as you see, prototype and market is kept outside because sometime this is an academic project that we are talking and the subject. So we would feel that you are able to come up with your own prototype, which is conceptual prototype, and not necessarily the product to the market. Once you have done that and you have tested and you get a good feedback, that's where then you take it to the market. But if you don't and you have not succeeded, doesn't matter, because you have understood the process and you have been able to create something original and innovative. And therefore we talk about testing and feedback, and then prototyping and market is kept outside the framework, whereas in the industry it would be inside the framework. So let's look at this framework further. If we talk about the projects, the project is given passion and purpose and need. What does that mean? Sometimes we find that the project is given by the faculty. Sometimes you find that there is a purpose or a need you want to solve, and sometimes it is your own passion with which you are able to come up with a project idea. So here the project could either be given, it could be your passion, or it could be purpose or need. How do we go about starting? By identifying a problem. So here is a very interesting fact, that most of the time when we say that we want to do a project, we say the faculty will give us the project, or we will try and find out on our own what are the kind of projects that happen. What I am saying here is, why can't we identify the problems from the real life? Like, you may be traveling by a bus, or you may be traveling by your own vehicle. And do you face any kind of a problem while you travel on your automobile? And if you feel, yes, I have this problem, then it is yourself, because you have experienced and found your problem there, and you could bring that problem to the classroom as a project. Why do we follow the self, others, and environment approach? And the reason for that is that whenever we look at ourselves and empathize, first we empathize with ourselves. We first feel, I would know more about my problems than others. Once we relate to self, then we move to the others and find out what are the problems of the others. And then we look at the bigger issues, because sometimes we are not able to connect with those problems because they are others or environmental problems, and we may not have experienced. For example, somebody may want to solve a problem on pollution, but unless the person has himself or herself not experienced that what is the pollution and what are we talking about noise pollution, and unless you have not experienced that on the street, how are you going to solve that problem, and how can you make it a project? So we generally use, because it becomes abstract, you have not experienced it. Therefore what we say is, first you look at self and find out a project from self, and you will be able to do much better because you have experienced it. Then you look at the problems of others. What do others face and what are their constraints and problems? Then while you're talking to them, you'll relate to them and put yourself in their shoes. And then you look at the larger issues and solve those. It's not necessary that you just have to begin from self, others, and environment. It is sometimes you may begin with environment. But please look at it, if you begin from environment, have you experienced it? So if you were to say, some of you may say, if you were to make the next iPad of the world, then you need to first have used that iPad for some time and experienced it and talked to many people and look at the technology behind it and then create it. The other better way would be, if you are using a laptop, better start from laptop which you have experienced and what changes you can make in that, go on to the next level and talk about mobile phones and what others are facing on it, and then later on combine these two and come up with the third solution, which could not be just a copy of an iPad today or a tablet. It could be something which you have originally created. So friends, what I am talking here is, when you look at your problem and finding problem for the project, it's better to choose projects that are from real life and that you have experienced. It could be self, it could be others, or it could be environment. So let's move ahead and see the next thing. It is emphasis upon learning by doing, and this we have discussed quite in detail, that we would always feel and take a leaf from Thomas Edison, that you need to take failure as a stepping stone for success. Because while you are doing while you use this process of learning by doing, there is a good possibility that many times while you prototype or you do research, you may fail and you may not reach the end, but the process that you have gone through will enlighten the future steps. So here therefore we are talking about learning by doing, that is by grouping things, by categorizing them, by prioritizing them, identifying the peculiarities from them while you are doing. So while you are doing all this, all these aspects and many more will come up, and you are able to learn in multiple ways while you are doing. So please understand that therefore it is very important for your projects to be real life projects. They should not be shelf projects. Otherwise the learning value is only 10 to 20%. In maximum you can say is 50%, unless you have experienced and created something and then tested it. So that's about emphasis upon learning by doing. And the last and important factor is the context. For example, if you were to look at designing anything and the context is large number of population in India, then the context becomes how can you make that thing cheap and less expensive, which can be without compromising on quality. Now here is a context. You want to make a product for masses, so you see how is the pricing of the product to be done, and then you work backward that what kind of product, and without compromising the quality and the value. So here you have looked at that context. Whereas if you were to create a product for higher end segment, then you look at that what is their requirement and how can I add value to something, or what do they actually need, and can I come up with a new kind of product for them. So please remember, the context of the project is very important right in the beginning. Let's move to the next step and let's look at the framework that we showed before. Here is the framework in detail. And if you look at the starting, we have a pre-problem stage. Generally most of the people when they get a project would straight away begin with the project, but here we feel that we need to have one more step, is search for the problem. So before you arrive at a problem, why not go around and search for problem before, and that becomes a pre-problem stage. Don't just find a problem or something from anywhere and start. Do a good amount of study on search for the problem is through self, others, environment. We move on to problem and objectives. We then move on to select, define and articulate a problem, the research and analysis. Here if you look at research, you can easily do a primary and secondary research. Most of the time students come back and say what we have designed is great, but later on while they have gone ahead in the end stages, they realize that the same product is available and in a better manner. It has more value for people. So in that sense, we need to move from very thorough primary and secondary research, which will also throw up multiple interesting and products and product ideas which you could bring back in your analysis. While you are doing your analysis, it's very interesting that you look at the gaps and hurdles right there. So before you actually begin with the project, which you plan the project, which is the stage ahead, you look at the gaps and hurdles, the collation and the correlations. You look at problems, resources and available to you, as well as the technology. Sometimes we move way ahead in a project and realize, oh, this is not possible. But if analysis is done here and you use analysis and synthesis together and you are able to define that in the beginning, it's very easy for you to go back to the project problem and re-articulate it for what is feasible for you. Therefore, we save a lot of time, and you also save upon unnecessary demotivating factors which may come in later in the study. So here by analysis we are talking about that we do a complete study of the feasibility. Then we say plan the project, and here we talk about build your web. When we talk about build your web, what we say is that can you build a network around you. The web could be people, it could be the resources, it could be libraries, it could be internet resources. Are you able to create a web around you? It could be material. So if you are able to create a web of people and things around material and technology, you could also look at the medium. So at that point of time, if you create a web of these ideas around you, then you will realize that while planning a project, after you have understood the resources, you get into your own web for the project. And that could also include mentor. Once you do that, we get into design-driven innovation process, which we have discussed before. And from there, you move to idea generation. Now, a lot of you may have this question that here is a framework that we are suggesting, but where are the tools and techniques? How do I go about scouting for ideas? How do I generate ideas? And how do I prototype? So don't worry, we have that section ahead where we're talking about how do you approach these steps. The next is prototype design, and where you could have a concept prototype that we were talking about, and you could do that multiple times. Then you get into technical feasibility, the economic viability and user desirability while testing and taking feedbacks. And mind it is going to be a loop. It's not a sequential process. As we saw, it is a cyclical process, which we saw before. So this is a cyclical process, and therefore you may go back from here to the planning of the project stage, or you may go to the idea stage, or you may go back to the even the problem identification and articulation, because it's a cyclical process. Wherever in the process you realize that I need to go back, and that's the time where you can redefine your project and make it more contextual and purposeful. So from there we move on to the prototype and the market. The tips that I would wish to share before we get into the details of the same is we need to develop our unique model suited to discipline. Now, why I'm sharing this? A lot of you students would be seeing this video and taking a leaf and making your notes out of it for subjects and projects. But all of you are from different discipline. All of you have different aptitude, your passion is different, and the resources available are different, and the outcome that is expected. So sometime when you look at the expected outcome, you look at, is it a first year project, it's a simple assignment that or exercise that you're doing for a subject, or is it a project of first year, or is it a final